Hello everyone and welcome to this video where we will be continuing what we started in the previous video about work and energy. So the last time we covered the term work and we found that work is equal to the force multiplied by distance, but the force and the distance must be in the same direction. So today we're going to be talking about energy. Now energy is one of the main foundations of life. With energy we can run, we can move. With energy, we can turn on a light bulb. So energy is needed everywhere and is seen all around us, okay? Now, energy comes in different shapes and forms. And energy can be transformed from one shape to another, okay? So let's talk about some shapes of energy that we see all around us. And we want to understand how to calculate them or how to find them or where these types of energy can be found. So let's start with the first type of energy, which is the kinetic energy. Now, the kinetic energy is the energy of any moving object. So any moving object has something called the kinetic energy. Other forms of energy is called the potential energy. And there are many forms of potential energy. But what does the word potential energy mean? Well, potential means hidden energy or stored energy. So sometimes you can't see this energy with your bare eyes, but the energy is there. And there will be proof that there is energy, okay? And we will be learning for each type of potential energy, what is the proof that this object has energy inside it. So mainly we have something called the kinetic energy, and it is the energy of any moving object. So if you're walking in the street, you have kinetic energy. A rolling ball on the ground has kinetic energy. What about potential energy? Let's see what types of potential energy is there. The first type is called the gravitational potential energy, okay? So when you lift a stone up in the air, you are storing gravitational potential energy inside this rock. And what is the proof that this object stores energy? So when you raise the rock up above the ground, you can't see that there's any form of energy inside it. It's hidden. It's potential. It is stored inside the rock. Okay, then prove that this rock has energy. Well, the proof is that when you let it go, it will move. And we know that nothing moves without energy. But you're going to say, well, yeah, that's common sense because gravity made it move. So in other words, gravity stored energy inside this rock. So the first form of energy is called the gravitational potential energy. Or sorry, the first form of potential energy is the gravitational potential energy, and it is the energy of any object lifted above the ground. For any object lifted above the ground, it contains potential energy inside it. The second form of energy is called the elastic potential energy. Well, when you pull a spring or a rubber band, you are storing energy inside it, but still we can't see this energy. What's the proof that this rubber band or this spring has energy inside it? Well, simply the moment you let go of the spring or the rubber band, it will move back to its original position. So the proof that this object has energy, it moved. Okay, but you said that any moving object has kinetic energy. Yeah, that's what we are going to be talking about in detail later on. What happened here is when I stretch a rubber band or a spring and I let it go, I am transforming the potential energy that was inside the rubber band that I couldn't see into kinetic energy since the rubber band or the spring is now moving. Okay? Now, for the third type of potential energy, we have something called the chemical potential energy. So when you burn fuel, if you have a tank of fuel, well, it's just liquid. How do I prove that this tank of fuel has energy inside it? Because we can release it when we ignite it. If we ignite this fuel, we are releasing the energy and we are releasing a new form of energy, which is heat. Simply, heat is a form of energy. So chemical energy is inside fuel, for example. Or batteries can also have chemical energy because batteries can store energy inside them and they can give it to electrons. They can give joules to electrons, giving something called the potential difference. For example, food is a form of potential energy. Food is another form of chemical potential energy because when you eat food, your body can maintain a certain temperature. So it's transforming the chemical energy from the food into heat. And it transforms it also into kinetic energy because when you eat food, you can move. Without food, you can't move. Your body will stop functioning. Another form of energy is the electric potential energy because electrons can carry and store energy. And another form, or the final form, is the nuclear potential energy. A nucleus of an atom has great forces holding the protons and the neutrons together. So if you were able to split the nucleus of an atom, a huge amount of stored energy will be released, called the nuclear potential energy. And actually, they use it to produce electricity. So these are the main forms of energy. But we are going to talk in detail about 3 of these forms. We are going in detail with the kinetic energy, how it's calculated. We are going in detail with the gravitational potential energy and how it's calculated. And we are going to go in detail with the elastic potential energy and how it is calculated. So let's start off with the kinetic energy. Kinetic energy is the energy inside any moving object. This energy depends on 2 main factors. It depends on the mass of the object and it depends on the velocity of the object. And they are both proportional to the energy. So a higher mass will give me a higher kinetic energy and a higher velocity will give me a higher kinetic energy. So for example, if we have a truck and a car, they are both moving at the same velocity. Which one will have a higher kinetic energy? It's obviously the truck because it has a higher mass. Kinetic energy can be found using this very simple equation. It's half mv squared. Just remember it, half mv squared. It's not very difficult to memorize. Half mv squared. Half, it's just half. M is the mass and v is squared. Some students, or a lot of students, forget to square the velocity. It's v squared, okay? So Ke is the kinetic energy. It's not K multiplied by E. No, it's Ke. It's going to stand for kinetic energy, and the unit of energy is joules. And we have the mass. The mass is in kilograms, and the velocity is in meters per second. Okay? So the first type of energy is the kinetic energy. It's equal to half mv squared, as simple as that. The other form of energy we agree that we will be learning more about is the gravitational potential energy. It is the energy a body gains when lifted off the ground because of the gravitational field. So the gravitational field is what's giving this object energy. And it can be found simply by this equation. The potential energy is equal to mgh. mgh. It's very easy. So the kinetic energy half mv squared and the potential energy is mgh. So gravitational potential energy, the unit of gravitational potential energy is joules, and the unit of mass is kilogram, which is m. G is the gravitational pull, which is equal to 9.8. And finally, h is the height the object is lifted above the ground, and it's in meters. The final type of energy we agreed on introducing is called the elastic potential energy, and it's the energy stored in a spring or a rubber band, for example, after being pulled or compressed. So changing its initial state from its length of at rest into stretching it or compressing it will store energy inside this spring, and it can be found by a simple equation. It looks very similar to the equation used to find the kinetic energy, but here we're going to say that potential energy, which is the elastic potential energy, is equal to half kx squared. So the potential energy elastic, it's in joules, and half is a constant. K is something called the spring's constant. The spring's constant is a constant number depending on the type of the spring itself. So every spring has a different spring's constant. It's a factor. You don't have to memorize any spring's constants. Mostly they will be given to you. And finally, x. It's very important to keep in mind that x is the distance that spring was stretched or compressed. It's not the final length of the spring. So for example, if I have this spring, it had, say, a length of 1 meter. Then I stretched this spring. The length of the string now became, let's say, 1.2 meters. In this case, x will be equal to 1.2 minus 1, which is 0.2. So it's the change in the length of the spring, not the final length or the initial length of the spring. So we introduced the most important 3 types of energies. We will be covering many questions, so it's very important to fully understand this lesson. Watch the next video where we will be solving problems. Stay tuned.